here to talk about the notifications API, and many of you might think it's funny that Nokia a corporation in this kind of environment, and why notifications API? Well, I'll start first with a history, what we have behind in this area, and then explain why notifications, and then present, of course, our API solution. So we basically started as an IM service in 2008. There was a client called OV Contacts available in several devices, and it was providing a basic chat service with a few nice little features like location presence and user tune and sending your location. But in the company during the year 2009, there started to be a shift to provide the main IM providers through our devices. So it wasn't enough to have a OV account-based or Nokia account-based IM in a device, because most of our users had the empty room problem, no one to talk to. So then we started to do, or not our group, which is still working on XMPP, but another group started to do IM with a gateway-based solution. And we started to think that the XMPP and real-time comms is basically more than chat. And you could do a lot more things with it. So providing application level messaging on a mobile space was something that we were starting to look into. And then last year in May, Nokia also made a strategic alliance with Yahoo to provide the IM and email via the Yahoo backend. So that was basically the end of the life for the XMPP-based chat service. Although it's still up and running, but we are not pushing too much effort on it, and it will probably close at some point. But instead, we look at the space in the mobile application creation and found out that this kind of a very simple push notification API is provided by all our competitors. Or if not at that point, it was at least coming. And we found out that we should do the same. Although we had already looked into a more elaborate cases of communication between applications, we decided to concentrate on putting something simple and doing it very well. So since that, we announced this kind of a push notification API in September in Nokia World. There was a developer conference at the same time, and we opened a restricted beta. And then in November we opened it up. So anybody from this room can go to the Forum Nokia site and get access to the tools to make applications on top of this API. And there will be a wider support on our devices during this year. So already now we support also a bit older devices, the so-called Symbian 1 5th edition devices, to name a few. So something like a few tens of millions of devices out there on the market which can support this. So how we decided to go to the push notifications? Well, if you look at, here's a screenshot of the most successful application at some point in the OV store, and start to look at them, you notice that at least half of them are using some kind of a notifications within the application, or could benefit from that. And at the same time, Accelerator made this study for the mobile application developers, and they stated that push notifications is really needed. If you look at the list, what they say that mobile application developers need, the first one, native user interface. Yeah, you cannot live without. Local database, well, that starts to be arguable. There can be some widgets or something like that without the database. But the next one, push notifications, even before internet connectivity, geolocation, and all those funny things that you can have with mobile. So clearly there is something that this is needed for. And then if you look at the effects that how people have gone around the problem of not being able to address the application on the mobile device. There are basically two methods. The other one is polling. So you constantly ask from the net, is there something for me? And then the net you typically answers either no, the most common answer, so you did everything in vain, or then it says yes and gives you the data. This is very bad if there are a lot of these applications on a device, because the battery will drain very fast. The other option is to make a persistent connection, a socket connection to your backend server. And it's sort of nice, but there's the same problem. Typically, there is something in the network that says that you need to have data going on either, or then they are going to close the connection. So you need to have a keep alive. And if you have 10 different applications in a mobile device, and each of them is going to make a keep alive, just to keep the connection open, and they are not synchronized together, then again the battery is dead before you say cat. It's too much burden. So what is a typical solution for this is to have a shared connection with only one keep alive. And at the same time, you're saving the battery, you're saving a lot of data consumption because you don't have to renegotiate the sessions. So you can have TLS on, and still, if you are using TLS on sort of a ask and forget, it's going to cost a huge amount of data. So basically getting the best of both worlds, being immediate, being lean, and not consuming battery. So what we basically offer is a simple API on the net side, a RESTful API, and then a simple Qt API on the device side to receive the notification. Not too many methods, so it should be fairly simple to try it. So here's the offering. And what we had as a design considerations is that we don't sort of dictate the flow, how it goes. So there were, in earlier presentations, for example, comments about using the push notifications and them cluttering the UI. So for us, the developer can decide whether it wants to receive the notification directly to the application, or whether it would like to use this kind of a common UI for handling the notification. So if you want to make an application which has a huge amount of notification received, and you want to handle whether you bring a UI on top or whether you just respond quietly with something. So basically, if there would be a daemon on the device, for example, answering the questions, where are you? It could receive the data from the GPS and then respond quietly every time there is a question. And the end user would not be harassed by any pop-ups or any cluttering in the UI. At the same time, if you decide to, you can use this kind of a UI so that each and every notification is coming first to an UI, so that you're certain that the user has made some action on it. And also you have a place where to propagate the information that your service is providing data, which is visible for the end user. And then, as opposed to some of the competing solutions, we allow payload. So very small amount, but still we allow payload, and we don't sort of mandate that you shouldn't use payload in your messages. Because typically it's a case of sending a notification which says that please fetch this information, and then you go to the Twitter and renegotiate a session and get 140 bytes of data. So for renegotiating the session, you probably used something like 8 kilobytes, and you kept the radio on for several seconds, while you could have had the same data already in the notification. Faster, cleaner, and just more efficiently. So that's about it. And what we do for the developers to keep it even leaner, so XMPP can be verbose, and XML and JSON, which are usually used for the payload, can be quite verbose. So we are using zlib. And even though zlib might not be the most efficient method for compressing, it's learning algorithm, and we are typically having long sessions. So the dictionary gets quite big and quite efficient. And also it's a quite lightweight to decode in the device. So the decoding part doesn't consume more battery than the savings in the network. So it's a balancing act. You cannot have a very strong algorithm there. And then the most important part which we have for efficiency is the heuristic ping. So there were a lot of discussion about how to make the connection reliable and also efficient. So the problem is that in mobile networks, different operators behave differently. So you cannot have one single keep alive. You need to know in which network or in which part of which network you are currently in. And we have a system that actually is distributed with the stacks, that the service every once in a while commands the client to make a probing session. So we are sort of sniffing the network on constant basis. We have a database where we give the answers to the clients that are connecting to our system. And thus, we have always the optimal keep alive so that the connection stays open, but it's not sending data too often. And this is really critical in a mobile environment, both in the sense of reliability, but mostly on the battery savings. So the other benefits, of course, real time. We think that the strongest point in the mobile device is that it's always with you. And the most interesting part then is what is around me now and what is happening now. So the real time aspect of it. And polling just doesn't cut. If it tells you something nice is happening, but you were there 15 minutes ago, then it's just too late. You went past it. And then we also allow this kind of a wake-up behavior. So you don't have to have your application up and running all the time. You just tell to the system that wake me up if there's anything. So we can save from RAM consumption on the devices. RAM is expensive, so we want to avoid putting gigabytes of them, at least in the lower end of devices. And also it is consuming energy. So if you have a process running, it will cost some battery life. And we are also using SSL or TLS, so connection is secure. And also we see ourselves here as a conveyor belt. So Nokia doesn't look into the messages and doesn't care what is in there. So we are just conveying these messages from the REST API to the application. So, like most of the other notification systems, there are a few steps. So, once the application is installed on the device, it registers to the notification service with one command, and then it queries for a notification ID, which is generated by the server. This notification ID is unique for the combination of one device, one user, and one application. So it is not valid in any other context than one person with one device, one application. And then it's the responsibility of the application to send the notification ID to its backend with the method that the application prefers. So we do not provide any additional tools, but sending it via HTTP isn't that hard. There is an example on the forum Nokia pages. And then the service just uses that notification ID to send HTTP REST code and whatever payload you want to have there, up to 1.5 kilobytes. Okay, so what do you need to do? Get the SDK, then try it out on the project side. There is actually a developer console, so you don't have to have the service up and running. You can send messages from the web page directly. And but before that, you need to register your service ID. So we have two different environments, the sandbox and the production. For the sandbox, you get your service ID immediately from the web page. Just say that this is the service ID that I want to use. If it's not reserved, it will be reserved for you. And then you get the password for the REST API, and you can start developing. And once you feel confident that it's ready, you press a button there for apply to production, and then some time goes by and most probably you will get an email with the new access to the new REST API and the new password. So when we have the clients on the market, we currently have a system called Smart Installation, so the stack can be downloaded for the older devices as well. But in any case, when the consumers get the stacks, they are pointing to the production system. And while you develop your application, you need to have a specific application from the forum Nokia web pages to direct your device to the sandbox. So you cannot mass deploy your application in the sandbox in this way. So then you publish your application. You can publish it in Office Store, but we don't dictate that. So you can actually distribute the application also some other way if you so wish. Okay, so it's an optimized connection with the service and client API, providing good ways to make applications which are up to the moment. And well, I don't go to the backgrounders unless there are questions related, but I would like to show one application which we just released in the beta labs. It was originally made just for the testing purposes of this whole platform, but the team sort of trying it out and testing with it thought that it's so good and cool that we need to publish it. So it is currently in beta labs, no mass distribution available, but it's basically a RSS reader with a twist. So I have here my N8 connected, and you can see from the home screen that there is unfortunately in Finnish, but there are the recent news which are pushed to the device. So device doesn't poll, everything is pushed, and during the presentation it shows 20 new messages. And when I tap it, it opens this kind of a reader, or actually it opened exactly the news byte that I pressed. And it does RSS, so we have a server in the network which is doing the polling for you for these RSS cases. And if the RSS feed happens to have the referring to the PubSub HubPub, then it reverts to the PubSub HubPub. So if the publishing is in real time, we will do it in real time. But if there is no hub, then we need to poll, and then there is a sort of a dynamic interval that we are using for the polling based on the amount of or number of items coming from that stream. So currently we use roughly 10 minutes, but it depends on the feed. So if there's more activity, it's shorter period. And from the first week statistics, I can tell that out of the about 4,000 feeds that we are using RSS for, from the 10-minute polls, 88% of the time they are miss. So should it be in the client polling 88% of the time, it would have the answer no. So not only you get the feeds faster, but you get them much more efficiently. So we have here also a pre-made directory for most common feeds. We just very briefly got them together, so you don't have to remember the feeds and write them with the Camposham keyboard of the device. You can just go there and think that /dot is cool. Let's subscribe, and then it says it's subscribed. And it's not showing the whole screen, but it shows that there are 3 new feed items from the feed that I just subscribed. Okay, any questions so far?
How do you get to know the notification ID of the application on a person's device? So how do I know that I have to send a message to that notification ID to make it turn up on your device?
So the application, once it has received the notification ID, needs to send it to the backend server itself. So it's up to the developer to decide how to get the ID to the backend service.
So the application can retrieve it from the mobile and just
yes. In the mobile there's an API call that get me an ID.
So I have a question, yes, from developer point of view. So in the simulator, you can test the push part of the thing, and you can actually connect onto the sandbox to get the notification from the...
Yes.
Okay.
So let me see if I could show it. So on the wiki pages, you would actually have to log in. The network here is pretty slow.
Yeah, so
I think the device did a remarkable job.
I'm asking the question actually because yes, for push from Apple, for example, to compare with, you cannot do push on the simulator. You have to be on the device to simulate the push, and it causes trouble for debugging. It's very painful because you cannot develop, get notification, test it. You have to upload before, and when you're going into the notification part development, it's really painful. So that's very handy part.
So here I have a list of my own services. is a part where you can sort of receive the notification ID, or since we are XMPP based, you can actually use the JID if you happen to know it. So as opposed to if you don't want to use the notification ID and you go for the burden of asking from the user for his JID, you can use that as an addressing method. And then the game changes a bit in a way that if the user happens to have several devices, then when you send with a JID, it will go to all of these devices that happen to be online at the moment. So instead of pointing to one particular device, it will go to all of them. So basically you add here the ID, then you define whether the message has the wake up flag on or not, and then you put the payload here and you just push. And this works also for the simulator, which I'm not going to open here because basically I don't have enough space on my SSD to have all the tools installed.
Yeah, and network is quite slow to respond. So
yeah.